In this video, I will explain you a very important concept called as binding energy. So first I will explain what is Einstein's equation, that is nothing but mass energy equivalence. Einstein has told that we can convert a mass into energy. We can completely destroy a certain amount of mass and that can be converted as energy. So this is a huge energy and this is the working principle of atomic bomb. Okay, so we can say that mass can be converted into energy. So for example, I have 5 kilogram of some substance, and let's say after some process this become 4.8 kilogram. I have taken all the product of the reaction, but still the total mass is 4.8 kilogram only. Where this 0.2 kilogram has gone to, that has been converted as energy. So on all other cases mass is conserved. Whatever the mass of reactant, that would be the mass of product. But whenever there is an energy conversion, whenever there is a mass energy released, that is energy from the destruction of a mass, whenever that is released, I could say that there would be a reduction in the mass compared to this reactant. Okay. Anyway, I will give you a better explanation. Say for example, we have an element X and its mass number is A and atomic number is Z. Can you tell me how many protons, how many neutrons would be present in this nucleus? Inside the nucleus, we have total A number of nucleons, that is the mass number, right? So A consists number of neutrons plus number of protons, that is Z itself. So Z number of protons would be there. So Z into mass of proton would be the total mass contributed due to protons. So Z number of protons is there into mass of the proton plus how many neutrons are there? A minus Z. See, A is equal to N plus Z and N is equal to A minus Z. So A minus Z number of neutrons are there into mass of neutron. So on adding these two numbers, we should get the mass, right? But on experiment we have found that when we are adding the total mass in this way, we will get certain number, for example 100. But at the same time, when we are taking the when we are taking the mass of the nucleus, the number is little bit different. I could say 98. I would repeat. See this, say for example, helium nucleus. So helium 2, 4. So 2 protons are there. So 2 into mass of proton plus how many neutrons are there? 4 minus 2. 2 neutrons are there. So 2 into mass of neutron. So 2 protons and 2 neutron, these are the total constituents inside the nucleus of a helium nucleus. So we are taking the total individual weight, mass of proton plus mass of proton, 2 mass of proton, mass of neutron plus mass of neutron, 2 mass of neutron. On adding, we will get the total mass of the members of nucleus, helium nucleus. But at the same time, if you are individually measuring the helium nucleus, the total mass of the helium nucleus, we found that this mass is little bit less than this mass. So this is called as mass defect. So mass of, what is mass defect? Delta M is equal to, which one would be higher? This would be higher. Okay, or I can say that as per the standard equation, Z into mass of proton plus A minus Z into mass of neutron. So this is total mass of proton, total mass of Z proton, and this is total mass of neutron, total mass of neutron inside the nucleus. So on adding these two elements, we will get a number, and that number is less than mass of nucleus, mass of actual nucleus. This is the equation. See, what has happened to this mass? Why there is a change in mass? This is called as mass defect, and this change in mass multiplied by square c square E is equal to delta m mass defect into c square. How does you get the value of delta m? From this equation, delta m into c square would get an energy, which means that on combination, or I can say that whenever in the case of helium nucleus, 2 protons, 2 neutrons, we have certain mass with us. Now whenever we combine them to form a small nucleus, then the mass is being changed, and when we are finding the mass energy equivalents, we will get delta mc square. So this much energy we have. Okay, now what has happened to this much energy, delta m into c square? That is used to bound the whole nucleons. See, it is 2 protons, right? 1 proton and another proton. It will have strong repulsive force, because we know that Coulomb's law is equal to 1 by 4 pi epsilon 0 q1 q2 divided by r square. Now whenever 2 protons are kept together in nucleus, 2 protons and 2 neutrons in the case of helium nucleus, so this distance is very small, so that this force will become very large. Now to overcome this force, we need certain high amount of energy to be stored inside the nucleus, so that everything can be bound, everything can be enclosed in a small entity called nucleus. Okay, so this much energy is present, delta mc square is present inside nucleus. Now I could say that, see, let's say the energy is some x mega electron volt for example. So this much energy is stored in a helium nucleus. So helium nucleus, delta m into c square, 2 protons and 2 neutrons are there in a helium nucleus, and it carries delta mc square energy. And what is delta m? Delta m is nothing but 2 into mp plus 2 into mn. We will get total mass due to individual proton and neutron present inside the nucleus, minus the actual mass of the nucleus will give us delta m mass defect, into c square would give us the mass equivalence of energy, and this much energy is stored inside the nucleus. Now if I am able to reverse this process, that is, now from 2 proton and 2 neutron this has formed, right? If I am doing in this way, if I am separating, I could say that this would release large amount of energy, delta mc square. Okay, so on breaking a nucleus, we will get its constituents and large amount of energy. So anyway, binding energy is nothing but energy required to bind the nucleons that forms nucleus of any element, that is binding energy. Okay, so this energy is equal to mass defect into velocity of light square. Okay, thank you.